Okay, Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. So in this video we are going to calculate the pH for the reaction between acid and base. So let's read the question together. So for the first question, so calculate the pH when 30 ml of 0.7 molar acetic acid react with 50 ml of 0.5 molar sodium hydroxide. And the Ka for the acetic acid is given. Alright, since we have the Ka value, so we know that the acetic acid is a weak acid. Okay, so this is the first information for the acetic acid, and this is the information for sodium hydroxide, and this is the reaction between weak acid and strong base. Alright, so first of all, to calculate the pH, we need to write a balanced chemical equation. So the reaction is between the acetic acid Alright, so the initial information, we have the acetic acid which is 30 ml and the molarity is 0.7 molar, and sodium hydroxide we have 50 ml and the molarity is 0.5 molar. So as I said previously, if you have all the information, make sure you only can compare mole. So you have to convert to mole initial. So the number of mole initial for the acetic acid is 0.021 mole, and for the sodium hydroxide it is 0.025 mole. Alright, so initially there is no salt produced. So the changes is according to less number of mole, which is negative 0.021 mole, negative 0.021 mole, and this is again 0.021 mole. And the number of mole final, this one complete. Okay, and what about this one? 10 to the power of negative 3, and this is alright. So now let's look at the final product. So now we have a sodium hydroxide which is a strong base. If you have a strong base, so we don't have to consider the salt produced. Alright, and then now we need to calculate the concentration final, which is 10 to the power of negative 3 over the total volume, which is 80 so you get 0.05 molar. Alright, so next, because sodium hydroxide is a strong base, so we only can compare, we only can get the pOH first. So pOH is negative log OH minus .30. So the pH is 14 minus 1.3, 12.6 Okay. So now let's look at question number 2. So calculate the pH when 30 ml of 0.7 molar acetic acid react with 20 ml 0.5 molar sodium hydroxide. Right? So now we still have to follow the same technique or the same procedure. We begin with writing the balanced chemical equation. The reaction is between acetic acid tambah sodium hydroxide produce so the mole initial, so the information given first. The information given is 30 ml (0.7 molar), and for this one 20 ml 0.5 molar. Okay, so we can have the mole initial, which is 0.021 mole, and this one 0.01 mole. And initially there is no salt produced, and we don't consider water. Okay, even though water have their own quantity. So we follow the less number of mole, which is 0.01. So minus 0.01 mole minus 0.01 mole, and it gain 0.01 mole. Okay, and finally this is 0. This is 0.01 mole, and for this one 0.011 mole. So now our final product is an acetic acid. Since the acetic acid is a weak acid, we need to consider its salt. So it exists together as a buffer. If the final product is a strong base or strong acid, we don't have to consider its salt. If it is a weak acid or weak base, we have to consider its salt because it exists as a buffer solution. Alright, so now concentration final, it is 0.011 over the total volume is 30 plus 20, which is 50. Okay, 0.22 molar. Okay, and for this one, okay, (0.2). Okay, so we have a salt which is 0.2 and a weak acid 0.22. Alright, so now if it, and because it exists as a buffer, so we need to use a Henderson-Hasselbalch equation to solve the problem. Because it is a weak acid, so the pH is pKa plus log, our salt is CH3COO and A, okay, negative log log okay. So you're supposed to get 4.7. Alright, so hopefully this video will help you to calculate the pH for the reaction between acid and base. Alright.